Good morning. I'm Parthipan from Information Technology Department. My project title is Criminal Profiling through Facial Recognition. This is my agenda of my project. Introduction. The main objective of this project is to develop a robust system capable of accurately identifying and profiling criminals through facial recognition. To achieve this, we leverage state-of-the-art face recognition algorithms and techniques to extract unique facial features from images and compare them against a database of known criminals. This research project addresses the increasing demand for advanced techniques in criminal profiling by exploring the integration of facial recognition technology. Statement of the problem. The current methods of criminal identification rely heavily on manual process and traditional biometric techniques, which are often time consuming, labor intensive, and prone to errors. Additionally, existing systems may struggle to accurately identify criminals across different environmental conditions and image variations. This project aims to develop an automated and robust criminal identification system using facial recognition technology to enhance the efficiency and accuracy of law enforcement operations. The scope of the project is to develop a comprehensive and efficient system for criminal identification using facial recognition technology. This system aims to streamline the process of identifying criminals by leveraging advanced computer vision techniques to analyze facial features and match them against a database of known individuals. By automating and enhancing the identification process, the project seeks to improve the effectiveness and efficiency of law enforcement agencies in apprehending criminals and maintaining public safety. Additionally, the project aims to contribute to advancements in the field of biometric identification and enhance the capabilities of law enforcement agencies in combating crime. Methodology. The methodology have totally 9 steps. There are data collection, pre-processing, feature extraction, database construction, model training, model evaluation, implementation, validation and testing, result and analysis. First, data collection. Describe how you will gather facial images and relevant data for your criminal profiling system. This may involve obtaining permission to access law enforcement databases, surveillance footage, public available images, or collecting data through control experiments. Pre-processing. Detail the pre-processing steps required to prepare the collected facial images for analysis. This includes tasks such as image resizing, normalization, grayscale, conversion, noise removal, and facial region extraction to isolate the features. Feature extraction. Explain the algorithms and techniques you will use to extract discriminative features from the pre-processed facial images. This could involve traditional methods like principal images, component analysis, or modern deep learning approaches such as convolutional neural network for future representation. Convolutional neural network is nothing but in our brain made up of many neurons. Every neurons connected one head to another tail. It is the same concept in this algorithm. Database construction. Describe how you will construct the database of known criminals, including the storage format, data organization, and indexing methods. Discuss any privacy or ethical considerations involved in handling sensitive biometric data. Next, model training. Outline the process of training your facial recognition model using the extracted features and the constructed database. Explain the training objectives, loss functions, optimization, algorithms, and validation strategies employed to ensure the model's accuracy and generalization ability. Next, model evaluation. Discuss the metrics and protocols you will use to evaluate the performance of your facial recognition system. This includes measures such as accuracy, precision, recall, F1 score, receiver operating characteristic curves, and confusion matrices to access the model's effectiveness in identifying criminals. Implementation. Explain how you will implement the developed methodology into a functional software system or prototype. Discuss the programming languages, libraries, frameworks, and hardware requirements needed to deploy the system in real world settings. Validation and testing. Describe the procedures for validating and testing the implemented system under various scenarios and conditions. This involves conducting rigorous testing, including unit test, integration test, street test, and performance benchmarks to ensure the system's reliability and robustness. Result and analysis. Present the result of experiments and analysis highlighting the system's strength, weakness, limitations, and areas for improvement. Discuss any unexpected findings, challenges encountered, and the insights gained during the methodology execution. Next, system architecture. System architecture is first we need to collect the criminal faces. Next, we need to extract the faces. After extraction, we'll store the images in database. Use pickle file. If we found any persons in camera to detect after pre-processing, we want to future extraction. After future extraction, match the person in criminal database. If match means criminal identified, otherwise not identified. Exit. Algorithm used. In this project, I have used facial landmark 68 algorithm. In this facial landmark 68 algorithm, divide our face into 68 points. The facial landmark 68 algorithm is computer vision technique used for detecting and locating key points or landmarks on human face. These landmarks include features like the eyes, nose, mouth, and facial counters. Hardware and software selection. Processor minimum Intel iCore i3 processor are equivalent. Memory minimum 4 GB RAM. Storage space in need for optimal performance. Python is the primary programming language for developing machine learning models and data pre-processing tasks. Next, implementation. Installing necessary software libraries, frameworks, and tools required for the project, such as Python, OpenCV, dleep, and any additional dependencies. Gather a dataset of facial images containing both known criminals and non-criminals. Pre-process the collected facial images to enhance their quality and standardize them for consistent analysis. This may involve tasks such as face detection, alignment, normalization, and image enhancement using techniques like histogram equalization. Establish a database to store the biometric profiles of non-criminals along with their corresponding information such as name, age, gender, and criminal history. Next, important code segments. These are some important code segments of my project. Output. In this, it is the my project output. In this ID, we enter the criminal name, criminal father's name, criminal's age, gender, date of birth. To store this pickle file. This is the database of my project. If we upload any person in this project, person image, it will identify whether he is criminal or not. Conclusion. The development of the criminal identification system using facial recognition technology has shown promising accuracy rates in identifying known criminal profiles. However, challenges persist in handling varying conditions, necessitating further improvements for real-world deployment. Balancing precision with computational efficiency and addressing ethical considerations remain critical for enhancing system reliability and responsible deployment in law enforcement contexts. Conclusion. In the future, we can make our project even better. One way is by improving how well it works in different situations, like when it's dark or if someone's face is partially covered. We could also use fancy computer techniques to keep getting better at recognition face over time. Another cool idea is to combine recognition faces with other things, like how someone talks or their eye patterns to make identification even more accurate. Lastly, we might look into using a special kind of technology called blockchain to make sure the information we gather stays super secure and can't be changed by anyone. Our project on automated criminal identification through facial recognition represents a significant advancement in the field of law enforcement technology. By leveraging state of the art facial recognition algorithms,